Hello, good morning, students. So today we will start a new chapter called as algorithms and flowchart. This is from the same unit from programming methodology. Last class I taught you from programming methodology chapter 1. So this is chapter 3, algorithms and flowchart. So what is algorithms and flowcharts? That we will see algorithms today. So what is an algorithm? An algorithm is a finite set of instructions used to solve a certain problem. It is used by the programmers to solve programming problems before writing the source code. Okay? So before writing down the source code or writing down the high level language, the programmers often they write down the algorithms of the programs. So what is that? So an algorithm must have the following properties: finiteness. The algorithm must be written in finite number of steps. That is number one. Number two is non-ambiguity. Each step should be written or clearly defined and understood. Number three is effectiveness. The operations performed in the algorithm should work precisely and be carried out in real finite time. So, in short, an algorithm, a finite number of instruction steps of the programs which the programmer is going to create, the source code. So, before the source code is actually built up, in an algorithm written in simple English language along with some few constructs are used to build the uh, program setup. So using that, programmers have an easier way of solving the problem before they start creating the source code. What should the following properties are? Number one is the finiteness. That means the algorithm should be written in a finite number of steps. So the number of steps should be, the programmer should be able to count. Okay, here the first it will start. Okay, in between there will be the inputting of the values and then the processing, and then finally at the last it will stop, like that. So each step should be clearly defined. Each step should be understood by the programmer and should exactly define how it should look in the program source code also. And then effectiveness means that as it is written in the algorithm in the programming source code also, it should work exactly like that and in finite number of time. Okay, now algorithm statements. The following statements are used to describe an algorithm. The statements in algorithm are executed in a sequential manner, one by one or one after the other. So in a sequential manner, the algorithms will start from the step 1 and move on to the step 2 and move in the step 3, like that. So the flow of the program structure will be sequential manner, means one after the other. So in that there is no construct interfering the uh, steps that is carried on. So it will move on from step 1 to step 2 to step 3, like that. A construct that allows to group several statements together using brackets. So in an algorithm it is possible that there may be several statements which are interrelated, so that can be formed as a compound statement. So you can have single statement, you can have compound statements. So the compound statements you can represent them using brackets also, or using some constructs. So number 3, same statements or compound statements can be repeated several times using repetition or loop construct. So when you have a single statement or a compound statement, two three statements which forms a compound statement, when you need it to be repeated several number of times, so you use a loop construct or you use a repetition construct, such as for loop, while loop, do while, and so that you use. Next is a constructor for selecting the next statement to be executed based on a selection condition. So when you need when there's a statement in the algorithm that needs to be executed, but it should be based on a certain condition, such as a boolean expression like true or false, so that comes under the selection constructs. So all of this can be used in the algorithm also, or can be uh, displayed on the algorithm also. So next is assigning a value to a variable in the program. So you can assign the values to the operands in the algorithm and show it and display it also like that. Alright, so this is defines what is an algorithm and what are the statements that you use, what are the statements that you can use in an algorithm. Next you have is, for the programmers, making an algorithm of a complex program, it makes it very easy to understand the flow of the program structure. And through that, since the flow of the program structure can be understood using the algorithm, making modifications on the algorithm is also done very easily. So before making any changes on the actual source code, okay, the programmer can make changes on the algorithm before the source code is even built. So any kind of error prompt or any kind of modifications needs to be done, it can be done easily on the algorithm because it is written in like simple English words. Hence, translating an algorithm into computer programs becomes easy for the programmers. So here I have an example to show programs for sum of two numbers in simple finite steps. So we have already seen this sum of two number samples. I've already explained it to you. So if you were to do the sum of two numbers programs, so before you actually build the source code, create the source code and execute that, it will be written in algorithm in this format. So it depends on the programmers how they can write down the algorithms, how they may want to write down the algorithms. So the algorithm is not exactly does not exactly have the syntax of the programming, but you can write down in your own ways, except that the first steps and the last step should you can use as a start and stop. So as you can see that in the step 1, it's the keyword used is start. So you're starting building up the program. In step 2, read A and B. So read A and B means you're entering the value of A and B from the keyboard. So that is why it says read A and B, that is accept the value of A and B and store it in A and B like that. Step 3 is sum equals to A plus B, so that is the formula. So sum equals to A plus B, suppose like 5 plus 4, that is 9, and will be assigned to the variable sum using the assignment operator equal to. So you can see that the program logic is also explained in there, how the program logic will look like. Alright, then in the next step, that is print sum, that is the in terms of programming source code, that is cout, display the value of sum, and then finally stop, so the program stops execution there. Now it can also be written in a different way by a different programmer, such as like this: step 1 start, step 2 input value of A and B, and then step 3 let sum equals to 0. So you can see that here it is even more explained, explanation is done even better. So like sum equals to 0, so sum is initialized the value 0. So here you can see that compared to the previous algorithm, to the above algorithm, here you can see that sum is also declared and initialized. Then in step 4, calculate sum equals to A plus B. So here you have you have a word called as calculate, so it tells a more definite answer, say like calculate, okay, do summation on this, and on this formula sum equals to A plus B. And then display, step 5, display sum of A and B, sum, and which stored in sum. So you can see that this is written more in like an English language, means like in English sentence. The above one is written in short format. So the below algorithm is written in a more complete sentence, which can be understood much better by the programmers. So but however, both of them are correct. Whichever way you write, it's both correct. So it depends on the programmers what kind of format to use for the algorithm. But of course, algorithm also follows some certain procedures, so you have to follow you have to write in that syntax of the algorithm language. So next you have is now an algorithm to compute factorial of a given number. So here you have still not encountered this program factorial, so uh, you won't understand much of this, but in the later chapters this factorial is there. So what is factorial? Is factorial of number is the multiplication of the number with the numbers preceding it. So example, as I've given here, to find the factorial of 5, you multiply the number 5 along with the preceding numbers, by the preceding numbers, that is 5 into 4 into 3 into 2 into 1, then you get the value 120. So factorial of 5 is 120. Factorial of 7 is you can multiply 7 into 6 into 5 4 into 3 into 2 into 1, which gives the value 5040. So that is how you calculate the factorial of a number. So if suppose factorial of 11, that would be 11 into 10 into till you get till 1. So that's how you calculate the factorial. So here, to represent it in C++ program, before that you have to write down the algorithm. So uh, so in algorithm you can see that at first step it is start, second step read n. So n is a number. So for the time you just go through this, you won't understand much of this, but when we come to the actual, when we do the actual factorial program, then you understand this algorithm. All right, so read n, that means accept a value from the keyboard and store it in n, so that n is the factorial number that you are searching for. Suppose like 5, so you are calculating the factorial of 5, so that 5 will be stored in n. Now in step 3, fac equals to 1. So since you have to since you can see that in step 5, the factorial formula, in the factorial formula, the fac equals to fac into ctr, it is mentioned there. So in order to since it is used in the formula itself, that's why fac is assigned a value 1, so that you'll get the correct output. At the same time, CTR, which stands for counter, or in place, if you remember the postfix increment decrement, where you use that uh, I or A, so like that, in such case, if you see that CTR equals to CTR plus 1, which is equals to A equals to A plus 1, which is similar to A plus plus, so that increment or decrement operator, that prefix increment or postfix increment decrement operator, is used in the loop in this format. So this increment or decrement operator, postfix prefix, it is used in the loop so that the loop can uh, continue, so that the loop can continue. So that's why here you can see that CTR is assigned the value 1, so that it will increment by 1 every time, as long as this loop condition is true, which is fulfilled by that while CTR is less than equals to 1. So this is a Boolean expression, so the while loop will execute on that Boolean expression, and if it is true, the compound statement fac equals to fac into CTR and CTR equals to CTR plus 1 will be executed. And as long as this CTR is less than equals to 1, then this formula will keep on executing. Okay, so here yes, there is a mistake. Okay, here it should be like CTR is less than equals to n. Okay, so I've made a typing mistake there. It should be CTR is less than equals to n, not 1. Then in the next step, that is print fac. So after executing of that formula, you'll get the value of the fac, and then finally step 7, stop. So later on explain this factorial program when we reach the control statements. Okay, so next is an algorithm to convert time given in minutes into hours and minutes. So this is the actually the second program that we have seen, and that I've explained on in operators and expressions. So since you are already familiar with this program and you have the source code with you, so you can compare the source code with this algorithm and you can match that. So as I've written this algorithm, you can see the first step is start, second step is you are initializing hours and minute to 0. Now in your source code also you can initialize the hours and minute to 0, but declaring this is same like declaring the variable actually. And then in the step 3, input time t, so you are entering the value of time in the variable t in minutes, as it is mentioned there in the question, time given in minutes. So you have to convert it into hours and minutes, so which is done in step 4, calculate. So the formula is executed. So by this algorithm formula you can see that okay, you can implement it like this in the source file also. So hours equal to t divided by 60, min equals to t more 60. And then in steps 5 and step 6 you can see that you display using the C output stream the R and then the min value, and then finally step 7, stop. Alright, so in the next video I'll explain some more uh, algorithms, okay, 2 3 algorithms, and then finally we move on to flowchart. So this is actually a very small chapter, but you have to understand the concept of algorithms and flowcharts nicely, so that you will find it easier to do complex programs. Alright, so that'll be all for today.